It's just a little starter project so we can really focus on kind of today's content and not have to worry about setting up the storyboard today. And we can really just kind of dive closer pretty quickly into our day's content here. So go ahead and grab that if you don't already have it. And then I'm just going to pull up the day's objectives here. So real quick before we get started, I think we have about everyone here. My apartment building they're doing a fire alarm test. They said they'll be doing it within about from now to an hour from now. So I'm not quite sure when it's going to be. So I've kind of set up my mic to be a little bit less sensitive. So you may, do I sound a little bit quieter than normal? No? Okay,
Not really.
I'm gonna turn it down a little bit just so my mic is a little bit less sensitive. Can you still hear me okay right here?
Yeah.
Okay. I'm trying to make it so that I don't like kill anyone's eardrums when it comes on and I have to really quickly just mute myself for just a second. So I hope it's not going to be too disruptive. Hopefully, it goes off during our break, but unfortunately, I don't know when it's going to be. So just a quick heads up. Maybe don't, if you're listening with headphones, don't like crank the volume just in case. So I don't want to damage anyone's eardrums. That would be really bad. Okay, so just if you're joining us, there were about 4 of you, I think, that joined, I think, before I said this, or after I said this. There is a starter project in the iOS16 channel that you can go ahead and grab. All it has is the storyboard pre-made for us. It's just a single view controller here, and we'll go over that. And it has kind of a blank stars view controller. So we'll kind of talk about that in just a second here. Today's project today is going to be dealing with basic persistence, and that the whole concept of persistence is, like it says here, it refers to storing data that can be loaded again the next time our app runs. So I'm sure you've noticed this, and we've really just glossed over it till now, is the fact that when we put in information into our app, it's fine, it works there, but then as soon as the app is closed, you reopen it, your data's gone, right? And that's not maybe a very great user experience for most cases, I'd say. If it's a calculator, you're probably fine. But if you're making some sort of a journaling app or a note-taking app, it'd be a really, really bad user experience if someone's, chronicling their day and then they save it and then they open the app to figure out that it's actually gone. So we're gonna be between today, let's see, Thursday, and also next unit, the second sprint of next unit, we'll be talking about a few different methods of persisting your data in order to get around that. They all have their pros and cons. We'll kind of talk about those. We'll be able to do a better comparison of these first two on Thursday. But this is a really good kind of easy, I guess, introduction into persistence. For everything that we're doing, it's great. And then when you get into Unit 2, you'll talk about another form, which is a lot more kind of robust and powerful, called core data, and why you would want to do that. So we'll get to that, kind of as we go along through this next month or so here. So the goal here is a few. These last two here, or really actually it's more like these 3 objectives here: make a class of struct conform to Codable, use FileManager, and use PropertyListEncoder are all kind of related to each other. It's kind of this pipeline of steps that we take in order to save our app's information. And we're finally getting into what a lot of you had questions about specifically from the Slido yesterday, but I think this has just been kind of an ongoing question, which is talking about a little bit more about MVC, getting into model controllers, which we haven't really talked about yet. So we'll also have a good discussion about those as well. And really, we'll kind of, I guess, have the full picture of MVC today, which I think is fantastic, and we can kind of get to talking about that. And not that it's on today's objectives here, we are also going to talk about, now that we kind of will have that conversation around MVC, we'll talk about organizing our files and a couple different ways that you can do that as well. So let's go ahead and just kind of, I'm going to show you the app and essentially what we have so far. Let me just pull up the solution project here. Or sorry, not what we have so far, but rather what we're going to be building towards, and then we'll go over what we have. All right, there we go. So we've got, it's really basic looking, although it gives us a good chance to kind of dip our toes into persisting our data. So the whole point here is for us to just save information about a star. So I don't actually know any real information about these stars. So I'm just kind of like fudging this here. But if we said like Mercury is, you know, I don't know, 12 light years away from the sun or something, I could hit this create button here. That would add it to this table view, but what's really cool is if I stop the app and then rerun it again, it still is there and it will persist as long as I want it to. And if we have time, I'd like to implement swipe to delete. We might be able to get away with that since we have the starter project today. So that's kind of our goal, and that's what we'll be working towards. So let's take a look at what we have here. In the storyboard, you should all have this already made for you, which is the entire view controller. There's nothing we need to touch in this storyboard. It's all completely made. But I don't think there's anything here that is new to you. We've got a couple text fields. We can see we've got a stack view, a horizontal stack view to hold this print stars and create button. And then we've just got that all in a single stack view. So we really only constrain this one item here. And then we've just got a table view that we've constrained to basically be the rest of the size of our view controller, which is about, I think it's 3/4 of the size of the view controller. Not that it really matters. Yeah, 3/4. And then going over to the corresponding view controller class file here, we've just got all of our outlets already made for us. And then we've got the actions also made for us. So we can really just kind of focus in on, you know, after you've got the views built out, you've got the view controller kind of all just created the outlets and actions for, we can just dive straight into what do we do next. Before we do that though, are there any questions about anything that you've seen, anything that I can go over to help you understand, you know, like what this app sort of comes with or anything, or do we feel okay? Okay. Can you give me a, just really quickly, give me a yes or a no if you have the project open and you're ready to go? This, specifically this starter project from the iOS16 channel. Okay. Israel, do you have the project open? Okay, cool. And Violet, do you have the project open?
Yes.
Okay, perfect. All right, so let's talk about MVC here. And we're gonna do some of my famously terrible drawings to illustrate it. Okay. So please, let's make this a discussion. I don't want to just talk and lecture you for the next couple minutes here as I'm just drawing things and you're just watching me. It's not necessarily quite as interactive as, following along in code. So um, please ask questions. This is your time to really kind of dive deep on a conceptual level into MVC. Excuse me. So let's make sure that we all understand this to the best of our abilities on a conceptual level, okay?
What does MVC stand for?
Perfect. Let's go over it. That's a great question. So talk about that. MVC. That's a little large. So it stands for model, view, and controller. So let's talk about what each of these even are, right? Like what constitutes one thing being a model, a view, or a controller? Can anyone give me, in their own words, I'm not looking for a specific definition here or anything, can anyone give me in their own words what they think a model is?
Like a pre-version of something?
Okay.
Like a structure.
Data of the app.
Okay, let's go with Wesley, and then I saw Ron after that.
Like a structure of your data.
Okay, a structure of your data. Yeah, perfect. So what data though? I mean, basically everything is an app. So I'm like purposely challenging you a little bit. It's a good answer. Let's go a little bit deeper. So what kind of data though in the app? Because everything is kind of data.
Is it the user data?
The user data. Okay, let's expand on that a little bit more.
Things that they input into the app.
Okay. Yep. Anyone else want to expand on that?
Things that you're viewing through the app.
Yeah, for sure. Things that we're viewing in the app, things that user puts in. Perfect. So, I mean, you could think of, I suppose, the color of a view as data in the app, right? But this is kind of like, let's put like the maybe like the users info information, so that you input or display to them. So just looking at our app that we're making today, what would be the model, do you think, if we had just one? What would be the model of today's app?
You'd have like a struct for the stars or a star.
Yeah, exactly. This a star, right? What about the Swift vocabulary project that we did a few weeks ago? What would be like the model for that?
Would be the words.
Yeah, the words, right?
Yeah.
So if you were creating an Instagram clone, what models do you think we would have?
Probably a user.
User, perfect.
Photos.
Okay, sorry, a couple of people talked at the same time. I saw Joe unmute first.
Like the photos, likes, followers,
Yeah,
etc.
followers, posts.
The whole feed, the feed itself.
Comments. The feed would probably, yeah, in a sense, it would, I guess, display like an array of the posts. So you're not wrong there. Although I think it's more of a visual element than anything. But, and that's an important part of the model. Their views and models are very kind of closely tied together, which we'll talk about in a second. So do we feel okay with the I guess the role or the definition of a model object? So it could be a class, could be a struct, it could be an enum, but it's going to be some data type that represents the app's information. Maybe I'll even put like, the app's information to be a little bit more, I guess, kind of broad and overarching. So I'm going to say to the user. That's an E. Okay, so let's talk about a view. What do you think a view is? Let's have you raise your hand so I can not have to just randomly call on someone. Okay, Violet, are you raising your hand or?
View is how that information or data is displayed.
Yes, perfect. Cody.
Sorry, I got you in two windows. Yeah, a view is an individual object in an application that will display model data.
Yeah. So we could put a view is really like any individual visual element that the user would see on the screen, right? So this could be, for example, a button that we interact with. It could be a text field. It could be this label. It could be the cell. It could be the table view in its entirety. These are all individually views, and that's where they sort of fit into in terms of MVC. Is they're just visual things that you kind of display on the screen. So in a sense, you could almost think about anything in the storyboard as being a view. Now, like the one exception to that is kind of taking this whole scene as a whole, because that really represents the view controller, which is slightly different. And we're going to get into that in just a second. But any individual element that you see in a storyboard scene would be considered a view. So a cell, a button, text field, label, etc. Those are all views. So I think it was Cody that was talking about this, which is there's this really kind of close relationship generally with the model here and the view. They're almost always going to be linked together in some way. We're building iOS apps, right? We're building some software that someone is going to use on their phone, and in that sense, it's very much a sort of front or user-facing sort of piece of software. It's not a database sitting on a server, in some server farm somewhere. It's the whole point of the app is to show information and data to the user. And so very often we closely tie the model and the view together, where really it's a matter of us taking some information from the model and throwing it onto the view so that the user can see it, right? Just like we have here, the model is a star, and we need, that's just some information. It's just an instance of a struct sitting somewhere in our app, in some file. But then what we do is we take that information and throw it onto a view to visually display, here are all of the stars that you've created. And in that sense, we have this relationship between the two. Wesley.
Yeah, can I just ask a quick question that's not really as relevant to this MVC, but how come we never have to import anything? Like how you mentioned, when we create a model, it just like knows that it's there.
Yeah. If you remember back to our conversation, and you may not have been there, I think it was in one of the Friday Q&A sessions, if I remember right, or maybe it was during another one, I can't remember. We talked about access control. So are you coming from a different language that you would have to import things?
Yeah.
Okay. So the reason that we don't do that in Swift is because of those access control levels. And by default, everything is marked as what you would call internal. And that means that it's accessible, or at least everything knows about everything else within the same module, but really you could, at this point, think of it as in the same app. So let me just real quick go back to Xcode here, and I can kind of show you a quick example. So everything that you make has this keyword kind of behind the scenes of internal. And that is basically saying everything else can know about it. So as an example, if I made a private struct called, private thing, I could access that here, private thing, it's in the same file, and that's kind of why, yeah, okay, that's kind of a weird example. However, if I were to go somewhere else, like another view controller file, and we're trying to find a private thing, it wouldn't recognize it. So it just has to do with these kind of access control, I guess, levels that we would call it. And by default, everything is sort of, in a sense, public, although I hesitate to use the word public because that's also a different keyword. Does that kind of make sense?
Yeah. Sorry for like get off topic. It just
No, that's fine.
throws me off.
No, it's great, and I think, you know, things like that can be a little bit weird when you're coming from a different language that isn't the norm, right? With Objective-C, however, you will be importing things probably more akin to what you are used to. So Objective-C is a little bit more, I guess, closed off in that sense.
Do views have to be like tables, charts, and graphs, or could it be like specifically for this app? Could I make like a big black space and it maps out where those stars are?
Sure. Yeah, that would be fine.
And that would still be under a view.
Yeah.
Okay.
It's really any visual thing that the user can see on the screen. It would be considered a view in a nutshell. That's a great way of kind of just broadly thinking about it, I suppose. Okay, how do we feel about views? Any more questions on views? Okay, let's talk about controllers now. Now, this is where we get into a little bit more of a, there's a little bit more, I guess, subtlety here. So really what we actually have are kind of two main kinds of view controllers. Model view controller, the whole point of MVC is really just to make it so that your app is organized, but most importantly, your app is modular in the sense that if you've separated the I guess components of your app out into models, views, and controllers, you would be writing your app in a way that would make it very, or I'm not going to say very easier, but a lot easier to, for example, refactor, or in other words, change or update or edit your code if you wanted to do something else. So as an example, and I'm not sure this is going to make a whole ton of sense to you because this is kind of how we've been doing it from the start. But as an example, if I change the way that my cell looks here so that it also includes some other label, there would be very, very little extra code that I would have to write, or maybe it includes an image of the star or something like that. There would be very, very little extra code that we would have to write on the other parts, like the models or the model control, or the models or the controllers, to make that work. As opposed to if you put all of your code in a single file and it was just all kind of woven together in what you would call spaghetti code, it would be a lot harder to kind of extract all of that stuff out, edit it, and, you know, change it essentially. So the whole point is for one, organization, but more than anything, it's for modularity so that we can edit things as we, you know, version 1.1, we change our app a little bit. It doesn't break the whole app. There's very little updates that need to take place. And also, just like I'm saying, expandability. So that's kind of a part of the modularity is when I want to add things to this app, it's not, again, going to break my app. It's just very kind of simple. Our code is what we would call it's like not coupled. It's not tightly kind of woven together. I'm not quite sure if that makes a ton of sense because we really haven't looked at like tightly coupled code because we haven't written bad code here. But so what we would then have is we would have a view controller, and then we would also have a model controller. I'm kind of purposely keeping this simple. Not everything that you write in an app, not all the code you write is going to fit within a model view and a controller, but that's kind of a later topic. Sometimes you'll have helper files and helper classes, but I'm really just kind of trying to focus on the biggest key components of, you know, architecting your app using MVC here. So we've used view controllers before. What is the point of a view controller as you've seen them in all of the apps that we've made up to now?
Just having a canvas that you can, view on the screen.
Okay, sorry, can you say that first part again? You kind of cut out there.
Having a blank canvas just on the screen, and you can add stuff to it. Can you hear me?
You cut out worse that time. Sorry.
Just a blank canvas that you can have on the screen and place objects onto.
Okay, yeah. You're sort of on the right track, and that's where we get a little bit into, this is a little bit tough. So the view controller, the I guess blank canvas is actually really a view here. So it's just a normal UI view that is actually just a view. So the view controller itself is actually not really anything that you would visually see on the screen here. And this is why I want to talk about this conversation, or I want to have this conversation, because I think it's a little bit weird to think about, because we've been talking about let's drag out a view controller onto the storyboard. But everything that you would see, even this kind of background, is in fact actually a view. The view controller really is represented seriously by this little yellow circle and like just this stuff up here that you don't actually see on the screen. Violet, did you have a question or a comment? No? Okay. Or you did? Okay. So let's take a look at maybe one of the old projects that we did. Let's look at the screens. No, that's not. There's not a ton going on in that app. Let's look at the hobby tracker. So let's actually take a look at specifically like this table view data source section here. Thinking about the view controller and thinking about what kind of thing a UI table view is, what do we kind of see that the view controller is doing in relation to the table view? Yeah, Wesley, go for it.
You're essentially telling it how many cells to display.
Yeah, so we are literally controlling the view. We are controlling our table view and saying, you need to look like this. Or, well, this is kind of a bad example as well. We could maybe go into the new friend view controller here. Again, we're saying, hey, I need to control what that save button does when I tap it, because the save button, all it really is a view. All it knows to really what to do is just be displayed on the screen, and that's about it. As far as what we want to do when that button is tapped, we have to implement that ourselves, and that is the job of the view controller, is to literally control the interactions with the view, whether it's what should be displayed on the view or what should happen when a view is tapped, etc. That is the job of the view controller, to literally control views. Does that kind of on a conceptual level make sense? Are there any questions about that?
So is it kind of sitting in between the model and the view and helping translate between the two of them?
Yes, that's actually exactly right. You're spot on there. We'll take a look at that. I'm going to draw a diagram here in a second, but yes, that's exactly what's happening. So I'm just going to put controls, controls, I can spell, interaction with views, and I'm just going to put, this is kind of not the be all and end all definition, but I think it gets the point across, where we're controlling interaction, like, what should the button do when it's tapped, but also tells views what content to display. do we, can you give me just like maybe in the chat here, because I don't want to pull up a Slido right now. Can you give me just like a 1 to 3 on how you feel with this explanation of a view controller, like your understanding of it? Okay. Okay, cool. Stephanie, I see your question in the Slido. I will get to that in just a couple minutes here. So let's talk about the model controller, just kind of basing what we see off of the view controller. What do you more or less assume the job of a model controller is going to be?
It's going to be in charge of how the data is displayed on the view.
Close. That would be the job of a view controller because it's specifically talking about views here.
Is the model controller going to be the data analyst for you then?
It not. Oh, how do you mean analyst?
Is it gonna make it easier to deal with the data and put it into the view controller?
Yes, in a sense, yes. So this is going to handle, handle any interaction with the models. So as an example, we have this really awesome acronym for what I mean by any interaction with the models. It's called CRUD. Has anyone heard of this before? If you've done programming in another field, this is not a iOS specific term. Has anyone heard of CRUD before?
Yeah, I have.
What does it stand for?
Create, read, update, delete.
Perfect. Yep. Read, update, delete. So if you're ever unsure what your model controller should do, and I know we've never made one and we will here, CRUD is the acronym that you should be thinking of to get you on the right track, just getting yourself started as far as what you need to do. So what this means is the view controller is handling interactions with views. The model controller just handles interactions with the models. So as an example, from now on, we will be using a model controller in our apps to create or initialize views, to read them or essentially get the values of our models, update them, and delete them. So again, the whole point of this is not to make it necessary. Well, I want to be careful when I say this. It's not to make it easy for us per se. The whole job of MVC is to make it so that we have parts of the app that have very specific jobs, so we're not stepping on each other's toes and kind of, again, creating that interlinked code that's really hard to update later on. So instead, for example, going back to here with our friends table view controller, this array of friends is going to, this is our hobby tracker app that we did last week. This, for example, really should be the job of the model controller to manage this array of friends. This is a model object that's being managed by a view controller, and that kind of, in a sense, breaks MVC. We're not quite following the rules here. We haven't done that because we needed time to introduce this to you, but from now on, we are going to have a model controller be the thing that holds like our array of friends. If we want to create one, for example, we'll have a function to create a friend instead of directly creating a friend here. Like that, again, is kind of a no-no, again, for the reasons of being modular. And if that doesn't quite make sense yet, that's okay. I keep saying, modular and, all of that stuff. It's a little bit hard to see when our apps are a little bit small in the sense that we're not dealing with multiple, different models and model controllers, and really the scale of the app doesn't necessarily lend itself to showing why this could be an issue, because right now it's really easy to just kind of manage everything that is in our app. We kind of know everything that's there. But as our apps get bigger and bigger, it can just be really overwhelming, and your files can get very, very long if you're not carefully separating them out like we are using MVC. Okay, more or less, I know we've never looked at a model controller, but more or less, do we feel okay with the concept of what a model controller should do? And if you have questions, please feel free to ask. Now is the time.
Can you maybe just do like one more example of a model controller?
Yeah, for sure.
Yeah, please. I can't, specifically how does it differ from a view controller? Because I'm not seeing the difference in the two.
Yeah, that's a great question. So really, as far as that goes, we're separating out the responsibilities. So the view controller's only job should be to manage views. So things that you would see on the screen, right? What does the cancel button do? What does the save button do when you tap it? What gets displayed on these cells? That's a very view-facing thing. That's like visually, again, view controller. It's what you would actually, the user would view or visually see on the screen. Whereas the model is almost like the behind-the-scenes underlying information for the app. We need something to manage interactions with that behind the scenes, right? Like when they, I don't know, swipe to delete, for example, we need a way to actually delete the underlying struct instance behind the scenes, right? We're not just deleting a cell here. There's always going to be that corresponding model object that that information behind the scene that we delete as well. And so we're just trying to separate out our concerns. So everything does one job, but it does that job really well. The view controller is going to manage the views really well, but that's its one job. If it needs to do anything with the models, like delete the actual data, the information series, that we'll leave that up to the model controller, and it can just say, hey, model controller, can you delete this thing for me, and so on. Does that kind of make sense?
Yeah, that clarifies it.
It's just like, here at Lambda School, I am the instructor. I'm not student success, right? I have my own job. Student success has their job, and we work together, right? We're on the same team. However, we have very different sort of job descriptions, very different things that we do in order to make the whole, machine that is Lambda School working. It's just giving one job to each kind of class here or struct, and it doing that job really well, in a sense. Kind of a master of one job instead of kind of being a jack of all trades, which could be a little bit messy as far as the code goes, if that makes sense.
Can I ask a question for clarification?
Yeah.
So does that mean like if you want to change like what the button says or what a cell says, that will go in the view controller, but if you want to affect the data, like what the actual model is, then it goes in the controller? Is that correct?
The model controller, yes, exactly.
Okay.
Yep, perfect. Okay.
Also, I'm sorry to interrupt. Before you go on, one of the things that I struggle with, and I'm not sure if it's relative to this or if it's a different topic, but like I always get confused and unsure like what goes in the view to load and how you know when you need to implement something in there. Is there a way that maybe we could do a lesson sometime on like explaining that? Because that's one of the things I still like don't get.
Yeah. I don't think it's quite going to fit into today's conversation, although worst case, I could just put together a quick video, just recorded something this afternoon and send that out to you guys on lifecycle function.
Could you? That would be so awesome, because I still don't like grasp that really and like know like when to use that and stuff. That'd be so helpful.
Okay. Yeah. Let's take a break, and during the break, I'm going to make myself a reminder to do that this afternoon. So
Thank you.
guys, yeah, you're welcome. I'll see you guys in 5 minutes, and then we'll actually dive into some code here. All right, welcome back. Did anyone have any questions come up during the break that they want to ask while we're waiting for everyone to get back?
So you can really think of the view controller as being between the display and the view model, I guess.
Yeah, yeah, in a sense. And really what ends up happening, and I mean, the model and the view are sort of like, the model is the underlying information. The view is like how that information gets displayed. So between the model controller and the view controller, it's really, yeah, like you're saying, kind of that interaction between, or I guess the connection between how the information gets displayed and what information.
And then, yeah, there's just the user input and all the data that that the user is sharing with the app.
Right, exactly. I'll kind of draw a diagram here after we write a little bit of code that I think will hopefully clarify a little bit of that.
Cool.
All right, we all back? We need another minute or two. All right, cool. Okay, so I'm going to pause on my terrible drawing, my terrible handwriting. We're going to jump into some code here. So let's go ahead and actually create a model object for our stars project. At this point, we have the views built out, in the storyboard, and we also have a little bit of the view controller. As far as building an actual app goes, sort of, I suppose what you would maybe call the workflow, the view controller tends to be the last thing that you actually implement. Excuse me, because that ends up being the place where really everything kind of gets connected together. So, like we just did, we can build up the views first. That's completely great. And we can start to set up the view controller. But then as far as like creating the star goes, we actually need a star object and we need a way to create that. So we kind of have to pause right here. And then the view controller tends to be kind of where you end up finishing as far as, some feature goes for your app. So let's kind of jump over to the model side of things. We've kind of spent, or we've got this starter project really kind of only focused on the view side. So let's go over and make a new Swift file. So just file, new file, or Command N. And we'll just call this star. So, and then we're just going to make this a struct called star here. And then we're just going to have two properties for now, and we're actually going to have to come back to this when we start talking about persistence. But first, I want to get the app working without persistence here, and really just kind of focusing on a model controller. So we're going to have a name that's a string, and then a distance as a double. And we're going to say, just as a comment here, this is in light years. I don't actually know if light years are two words or one. So again, this would be going back to our terrible drawing of MVC here. This is that app's information, right? This is the information that eventually it will be displayed to the user as, but really it's just, a string and a number. And we ultimately will end up showing it to the user, but really it's just kind of information behind the scenes. Just think of it as almost like a file on your desktop that's just storing some information. File's there, but then you have to actually open the file, pull into like a text editor in order to see it, and that would be kind of like the view. So we'll just kind of leave that there for now. Any questions on this star struct here? Okay. So let's go ahead and make another Swift file here. And this is going to be our model controller. So as per sort of the naming convention, really all you would do is you would say, put the name of your model, so star again, then I'm just going to say controller at the end. So I know this is a model controller, but specifically it will be controlling my star model object. So if we had multiple models, like a star and maybe a spaceship and a planet, those would all probably have their own model controllers. So you'd have a star controller, planet controller, spaceship controller. It's a little bit flexible, and that kind of comes with time as far as, you know, if they're really quite similar, you might chunk them together, but as a general rule, every model should have its model controller. It's just a Swift file. Thanks for like all of you chiming in, that's awesome.
So that means if you make a model of something, it needs a controller, so that way you can use the CRUD methods for it.
Exactly.
So
Yeah.
every model needs CRUD methods set up because we're changing into apps that have more functionality. And then when we did these other apps, they were just more for like learning kind of thing. Is that the difference?
Basically, well, let me go back to. Do I still have it open? Let me go back to the hobby tracker. It would basically be the model controller will be a place where we can actually put like this array of friends instead of it. Instead of it being in the view controller, it's basically managing an array of models, which kind of isn't good in terms of MVC as far as kind of the overall job descriptions. It's now like the view controller is being both a view controller and a model controller, and we want to get away from that.
And that's what they mean by like the massive view controller, right? Like eliminating that. So giving everything its own job would negate that, right? That's what you're saying?
It helps negate it, yeah.
Okay.
Or, you know, in over here where we're creating the friend object in the view controller, that's also something that the model controller should be doing.
Would the delegate also go in the model then? Like where the delegate is down there, where does that belong?
No, that's fine here.
What is that considered? Sorry.
Well, it's not really a part of MVC. It's more, it doesn't necessarily fit into MVC at all. It's sort of a connection between two view controllers in a sense. It's not necessarily one thing or the other. It's a good question though. So we'll just call it star controller here. And this is just a vanilla Swift file. So just like as if we were making another model. As far as model controllers go, I'm going to have you put this comment here because I want this just, if you use this as a reference, we're going to talk about why later. It's not really probably going to make a ton of sense now, but model controllers should be classes. Not structs. We'll talk about why this is, but essentially the reason that it has to, or it should be a class is we're going to be using this model controller in multiple different places. And in order to not duplicate our data and be dealing with some issues that can happen with that, we're going to make it be a class so everything can reference one original model controller. And if that doesn't make sense today, that's okay. We'll be looking at an example where we actually are using multiple view controllers and kind of, yeah, exactly, because of reference and value types. We'll be looking at an example of why this could be an issue later this week. So no worries if that doesn't make sense. I just want you to kind of, even if it's a little bit blind at this point, I want you to sort of blindly follow and just trust me here that they should be classes, and we'll get into why.
Does this have to do with memory or something else?
Less about memory management than it does. We want everything to reference what you would maybe call a single source of truth. And if you're
Okay,
using value
that makes
types, it can
sense.
be really easy to duplicate that source of truth. And then you're dealing with, instead of maybe an array of stars, you've got multiple arrays of stars where if you change one of those, it doesn't actually propagate through all of those arrays. And we want to kind of keep one source as, you know, that this is the exact, literally source of truth. This is what our stars should be. I think it'll make sense when we get into an actual concrete example later on. So again, we're just going to make this a star controller. Just like we named it starController.Swift, we're just going to call the class starController. Struct is the blueprint for the model, and the model controller is how we reference it. Yeah, basically. Wait, what? Sorry, I don't. Joe, what is wrong?
I was just talking to Cody. Sorry.
Oh, you're good. Structs are. Oh, I didn't see that one. Structs are great, and they definitely have their place. But if you're coming from, you know, a C style language, then they can be a little bit weird for sure. I definitely get that. Okay, so again, can anyone remember the acronym that we need to use for our star controller? If we're kind of, you know, having this deer in headlights, which is totally normal, we're like, I just made a new file, I have no idea what to put in here. What should we kind of think about?
CRUD.
CRUD, perfect. So for us, we're not actually going to have a full set of CRUD methods. Like we're not going to have an update and a delete method, but it gets your head in the right place. What we will have is a create, and we'll also have read. So as far as create goes, this is going to look weird, and I think, well, yeah, I think you'll have some questions about it, but we'll answer it. So we're going to have a function here called create star, and then we're just going to pass in all of the information that a star needs to be initialized. So what information do we need?
Name and distance.
Name and distance, perfect. So we'll just say name as a string argument, and then we'll have another argument that is a distance as a double. Sorry, my voice is kind of running, or my throat is really dry today. Well, no, I'll talk about that in a second. Okay, so really the whole job of this is going to be literally create a star at the least. And this allows us to do more than that, and I'll talk about that in a second. But for now, all I want to do, and it's going to give us a warning here, just a yellow line, because we're not going to quite use it yet. We need to talk about read, and then we can come back to this. So we're just going to say let star equal star. We'll pass in that name and distance from our arguments here. So I'm going to just kind of do this. So we put the name right there, distance right there. Okay, what this really means is the create method is in charge of initializing a star. So from now on, you should never initialize a star outside of the model controller. That's kind of the whole job of the model controller, is to create one for you. This may seem a little bit roundabout, and in a sense it is. We're kind of going through another class just to have it call the initializer for a star, which seems a little bit weird. But again, it's for that whole concept of modularity that may not make a ton of sense right now. You might just have to trust me on this one for now. But at the very least, we have a star. So this would be taking the place of like us in our hobby tracker app. Instead of us directly creating a friend object, we would say something more like, and you just watch me, this is a completely different project. We would say something, if we had it, like friend controller dot, create friend with the new name, hometown, hobbies, etc. and it would do essentially the same thing. But again, it's all for the sake of that kind of decoupled, reusable code. So just keep that in mind. Again, if it doesn't make a ton of sense why you would do that right now, just kind of regurgitate the code at this point, and it will kind of come in time. So what we could do is we could kind of customize this a little bit. We have a little bit of flexibility to say, do we want to do anything else with this? Do we want to, be able to return the star here? And you can just watch me here. I'm not actually going to keep this. But we could say, we could return the star so someone could use it somewhere. Or do we just kind of want to keep this in here and just say, we'll create a star, but we'll kind of put it somewhere in the star controller itself? There's that little flexibility there. For us, what we're going to do is I'm going to say, well, we kind of want the star controller, again, to be managing all of our stars, just like we want to get away from doing this, where our view controllers are managing an array of friends here. That's kind of a bad thing. So we're going to let the model controller instead be the one to have an array of stars. And if we create a star, we probably just want to immediately put it in that array if that's going to be, for example, where our table view is going to be looking for its data here in the view controller and by extension, the table view. So let's talk about read here. I'm going to put read above here because it's actually we're making it as a property, not a function, just to kind of make more sense. So I'm going to put read here. I'm going to put stars as an array of star objects. And to begin with, as soon as the app runs, we could just set it to be an empty array. We maybe just don't quite have any stars yet.
Can I ask why that's read?
Definitely, yeah. The reason that it's read is we're basically going to be reading this value of our array of stars, for example, in our table view, and so that's essentially where the table view controller is going to read the values that it needs to give to the table view. So it's really like you can think of read as how do I get the information about the stars in my star controller? This is just one way of doing it. You could be reading from core data. You could be reading from a host of different places, but by and large, for the most part right now, your read is just going to be a variable that is an array of your model object.
Is it read because we're not manipulating it or creating it?
Mm-hmm. Yeah, you could think of read as just like get the value of these stars, right? You're just reading that value. We're never writing necessarily that value. We access the stars just in a get fashion, then we're just, reading that value. But what this lets us do, and we'll come back to this because this is kind of where we will link up the views with our model controller with the stars array, and we're just going to kind of use this array to populate our table view over here. So in order to actually put some stars in this array, what we could do is, as soon as we call our create star function, we could immediately say, well, I just want to put that star right in that stars array so it's ready to go for the table view to view or to be shown on whatever visual element our app has. So we can just say stars.append our new star that we just made. So again, stars coming from this variable right here. And we're just going to add that new star that we just created here. So it's basically as soon as the user creates a new star, we're going to, in this create action later on, we'll just be calling the create star function. And what it's going to do is it's going to, take the information from these two text fields, pass it into this function for name and distance. And then immediately we create the star, but we also just throw it in our array of stars so that it can be shown on our table view here. How do we feel with this? Questions, comments?
Can you repeat that last sentence you just said?
Yeah. So this is ultimately going to be kind of taking the place, I suppose. This create star function is going to be taking, or really what we do when we tap that create button, is it's just going to create the star, and immediately, just as soon as the star is like created, we just throw it into our array of stars up here for safekeeping, so that anywhere else in the app can just immediately use that array of stars to, for example, be shown on the table view here. Whoops.
So is this to, in the future, prevent like questions like, where did I create that thing again? Like,
Right.
where was it created? Because you always know where it was created. You just have to find where you called this create star function.
Yeah. And it's making it so that, just like you're saying, where did I create this star, and like thinking about, did I, add it to the array, or did I forget to do that? You just call one function and it's always adding it to the array. So you've just got that kind of added benefit there of just, it's almost like a peace of mind. It's going to create one, but you also know if you're calling this function, it's immediately adding it to where I want it to go for access anywhere else in the app, essentially. Let's kind of continue with this. Let's jump back over now to the view controller and kind of set this all up and kind of connect everything. And I hope this will kind of click, because right now this is just very conceptual. We're not using this quite yet. So let's actually kind of jump back to the model controller and the view controller interacting and kind of go full circle with all of MVC here. Does everyone have this? I'm going to switch files here. Okay, cool. So let's go to the stars view controller. And now here is where we can set up the rest of the app. We kind of have, we've gone full circle here where we've set up the views, but now we also have the model and the model controller. So we've kind of done everything we need to in order for MVC to kind of be, I guess, complete. So we can now finish out our view controller here. Let's go ahead and, did someone unmute? Someone have a question?
Oh, I did. I didn't realize that you had heard me, but my it looks like my buttons and outlets and actions are no longer connected.
That's okay. Sometimes it will do that if the storyboard just isn't open.
Okay.
Okay. As long as you haven't, messed with the storyboard or anything, you should be okay.
Okay. Thank you.
Yep. So let's go ahead and set up the table view first. Now, in order to connect our stars view controller with our star controller, we just need to create an instance of a star controller. So all we need to do is just say let star controller equal star controller. And I'm just going to put make an instance of the model controller. And that's really how you connect the view controller and the model controller together to be able to, get access to them, or get access to the model controller from a view controller. And then with multiple view controllers, it's a little different, but we'll kind of go talk about that later. And let's set up the table view first of all, and then we can talk about these two actions, and specifically the create star and print stars if we have time. So
I'm sorry, where did it get that data type from? Star controller?
That's the class that we just made here.
Oh, okay. Got it. I'm a little confused as to what it's doing as well.
So all we're doing is we're just initializing a new star controller. So we're just, creating an actual sort of tangible instance of this, star controller that's going to manage stars for us. Does that make sense?
So it's making the reference to it, right?
Yeah, and it's actually creating one as well. But yes, it is creating a reference to one. So we've got this view controller, right, which is this one. So behind the scenes in code, it's like we've just created a new manager to say, hey, can you manage all the stars for me? And it's just going to be an instance of the star controller. Yes, exactly. By putting the open and close parentheses right here, we are initializing it and creating that instance, like a tangible version of the star controller. Just again, like going back to our first week where we had that like coffee, right? That coffee struct, we had the idea of coffee, but then when you wanted to make one, you would say, you would open the parentheses, pass in all the values you needed, and then it would create the tangible instance of coffee. Same thing.
I thought to make an instance, you need to provide it a name and distance.
For a star, yes, you do. That's exactly right. But for our star controller, it doesn't actually need any values to begin with. So for a star, you're exactly right. So this is the initializer for a star. It just turns out for the star controller, this whole thing, everything has a value, so we don't need to pass anything into the initializer or even create one to begin with.
Do we have to make those properties in the star controller static in order for the new star controller to access them?
No. Like stars here or create star?
Yeah, I mean, any of it.
No.
Don't they have to be static to be accessed from the class, just the class?
No, because these are instance variable. This is an instance variable and an instance method or function. So as long as you have an instance of a star controller, which we do have, I can say lowercase star controller dot stars, and it's accessible that way. If I was just using the idea of the star controller and I hadn't actually created a tangible version, then yes, we would have to make this static. This is very much the same as us creating a tangible instance of a star where Mercury is its own instance, Rigel is its own star, and Sirius is its own star. They're all their own instances. It's just we're creating an instance here of the star controller in this view controller behind the scenes. Just like you make your own instance of coffee, this is just an instance of a star controller. Have I confused us all? Any questions or comments on that one? Okay, let's continue on, and then I'll try to circle back if we have time. Yes, that's exactly what allows the view controller to access what we created. So let's go ahead and set up our table view. So again, I'm going to try to keep this a little clean. So we're going to make an extension here on our stars view controller, which is just this view controller up here. And we're going to set our stars view controller and say we need to adopt the UI table view data source protocol. And so the two functions we need are the number of rows in section and that self row at index path. Let's keep going, Cody, and then I'll try to kind of circle back and see if maybe a question will form as we kind of go on here. Very, very relatable. That's true. Half of the work I think is coming up with the question itself. So it's going to yell at us here because we're not adopting the protocol. So we'll just hit fix to get those two functions that we need, the self row index path and the number of rows in section. So as far as the amount of rows that we want, how many cells do we want? Not necessarily thinking about where they come from, but like, how do I know how many cells I want on my table view here?
You want a cell for each star in your star controller.
Yeah, exactly. So we just want one cell for each star, and it's just in the star controller. So going back again to this friends table view controller, when the array of friends was right in the table view controller, we just said return our friends.count. All we have to do in this project is it's just in our star controller's array of friends. So we're just going to say return star controller dot stars dot count. So it's just kind of one level deeper in our star controller, but the process is the same. So everything we've been doing up to this point without a model controller isn't invalidated. We just barely have to shift it, and everything else works the exact same, like we're used to. It's just the array of the, or sorry, the location of the array is in a slightly different place, but everything else around it works the exact same. So we're just going to say, oh, sorry.
It was me. So we were saying star controller dot stars dot count because the array is not in our view controller, it's in our model controller.
Exactly. Yep. It's now just located here.
Okay.
We just kind of need to point the table view in the right place to say, well, I, the view controller, don't know how many rows you need, but you know who does is the star controller. Just go look at its array of stars and how many there are in there, and it'll give you the answer.
Thank you.
Yeah, great question. So then for the table view, we'll just do that whole let cell equal table view dot DQ reusable cell with identifier for index path. That's that one line that we get for free when we're using a table view controller. And our identifier should be star cell, capital S on star and capital C on cell. And then index path, you can just drop in the index path that we get from the argument to this function.
I'm getting errors and it's not letting me autofill the UI table view cell. The functions that you have.
Okay. What does it say?
It just use of undeclared type UI table view data source.
Interesting. Are you doing that in the stars view controller?
Yes. No, I am in star controller.
Okay, that would be why. You can just copy or cut all of that out and throw it in the stars view controller and you should be good. So quickly, I know that like sometimes I'll move around files, and a problem that I see often is I can sometimes go to a different file, but it actually isn't selecting the right file over here. So when in doubt, if you're looking at which file I'm in, look up here. That will always show the correct file that I'm in, and this little ribbon up here. Don't necessarily trust what's highlighted over here. Sometimes it doesn't actually display or highlight what's the actual selected file.
I probably just copied the code wrong, but I'm getting unnamed parameters must be written with empty name, insert underscore colon, use of undeclared type, number of rows in section.
Can you share your screen real quick? Or are you on a different computer?
I'm on a different computer.
Okay. Let me do this. Let me copy this to you.
Okay.
And then I'm not quite sure. I apologize.
It's okay. Thank you.
So once we've got the cell here, what is probably the smart thing to do is just grab the instance of our model here so we don't have to keep going back to the array over and over again to get the star, and I'll show you kind of what I mean here. So I'm going to say let star equal our star controller dot stars index path dot row. Again, same thing, just like we've done before. It's just where that array lives is a little bit different. It just is now in the star controller, but this whole process should feel very, very similar to what you've done previously. And then we can say cell.textLabel.text, which is going to be this top one here. So we'll do the name of the star on our text label, and then we'll do the light years away in the detail text label. So we'll just say equals our star dot name and cell dot detail text label dot text equals. And then since our distance is just a double, let's do something like this where we interpolate the star dot distance, and then we'll just say like light years away. And I know I'm not handling when it's like a single light year. Again, we're not going to worry about that right now. And then finally, to have it stop yelling at us, we just need to return that cell so the table view can actually take that and display it. How do we feel about what we've done in here? I know it's a little different. Any questions?
Yeah, can you hold up a second? I am so far behind. I don't have most of this code done yet.
Okay. Yeah, for sure. So really, again, we're just, let me pull up the simulator here. This is, again, just us asking or us telling the table view how many cells it needs. So in this case, it's going to say 3. We've got 3 cells in, or at least in my app, I've got 3 right now. Right, the count of my stars array currently is going to be 3. So it's going to say, oh, sweet, I'll make 3 cells to correspond with that. And then the cell for a row at index path, remember, is just going through each cell and saying, okay, for the cell at index path row 0, what information should be displayed there? We say, let's make a cell. Again, that goes back to that conversation we had a little bit about dequeuing and what that means. It's going to try to reuse a cell if there is one that it can just kind of recycle, or it will make a new one. If there isn't one available, like as soon as the app's starting. And then we can grab the star. I mean, again, going back to our conversation about MVC, it's really a matter of us taking that model information and displaying it to the user on the view. And so we grab a star, which is that model information. And then we just kind of throw that model information into our text labels by saying, hey, text label right here, your text is going to be the name of the star. And detail text label, your text is going to be, X amount of light years away. We're just kind of slowly, individually passing parts of our model onto the view side and just kind of going down the line there until, all the views have every bit of information that we care about from our model.
Those numbers should be so much bigger.
I'm sure, no doubt, no doubt. I don't profess to know anything about space whatsoever. I'm going to paste in this extension for anyone that needs it here in the iOS 16 channel. Are there any other questions about what we've got here so far?
Well, I've got a question, and I'm also getting an error in this code.
Okay.
Oh, it went away. The error didn't go away. The code went away. It's 45 on your screen.
Uh-huh.
Let star equals star controller. I'm getting value of type star controller has no member.
Okay. Do you have it spelled star controller up here?
Oh,
like lower.
Where is that?
Just scrolling up a little bit from that extension.
Oh, star controller lowercase s. Yeah.
Okay. In your star controller, do you have this bar of stars?
Wait, is it star controller dot star or dot stars?
Stars.
Okay, that's probably why.
Okay.
Yeah, that just lit up. Okay, and my question was so it's 47 and 48 on this view controller on yours.
Mhm.
What are those question marks doing? Like, why are those optionals there, and how come I don't have to unwrap it?
Yeah, so again, that's optional chaining. So that's just us kind of saying, hey, I know that this cell, in this case, it looks like your text labels property is optional. So it just could or could not have a label. And if we think about this, that kind of makes sense, especially if we think about like the detail text label. Some of those cell styles have that detail text label, which happens to be this smaller one. And then, you know, like the basic cell style just doesn't. And so it could or could not be there. And so all we're saying with the question mark here is we're using that optional chaining to say, hey, if a text label does exist, can I just kind of directly access its text property and set that without having to unwrap it myself? It's just kind of a quick way of not having to unwrap the label before we use it. Because in this case, we don't need to unwrap it to use it. Does that kind of make sense?
Honestly, not even kind of.
Okay.
Why don't you have to unwrap them? That was my whole question. I don't understand how you can have an optional and not have to unwrap it.
Basically, what optional chaining does is it's going to try to unwrap it for you behind the scenes. But if it fails, it just kind of returns nil and doesn't do anything. It's more like a no-op, like a no operation. It just doesn't do anything. It would really only be an issue if we didn't unwrap it here, if we had, you know, a function that takes in a non-optional label that, like, no matter what, has to be a non-optional UI label. But if we're just accessing a property on an optional value, optional chaining can kind of do that, or try to do that unwrapping for us behind the scenes. It's just a language feature to kind of make it so that you don't have to unwrap it if you don't need to. Does that help a little bit or no?
I mean, I kind of guess I get the gist of what you're trying to say.
Okay.
I don't know.
If you want, I'm more than happy to talk about. We could talk about optionals or anything that you want, like later on, maybe this afternoon or sometime later. All right. So at this point, the app should be functional to the point where we would be able to see something on the screen. So let's just go into our create star function and make it so that we can actually add something into this array here. So as soon as I'm gonna maybe pull this over here so I don't have to keep tabbing. So as soon as we hit this create button, it's gonna call this action. So what do we, just on a conceptual level, not talking about the exact code we need to write, but what do we want to have the app do when we tap the create button?
We wanted to call our create star function from the star controller.
Yep, exactly. We want it to call our create star function that we have over here. That's ultimately the thing that really should be creating the star, because that's the job of the star controller. So let's kind of start to do that. Let's say star controller dot create star. And so we need a name and a distance. So where are we going to get these two values from here? Because you're right.
The
I
text,
mean, yeah.
Sorry, can you say that again, Joe?
the text labels.
Yeah, perfect. We have our text fields up here. So let's just go and grab those texts. So kind of going back to the concept of optional chaining, this is a time where the text labels, so you just watch me right here. The name text field .text is also optional here. This is optional. So if we wanted to use it, that's fine as an optional. However, looking at this name, the requirement is that it's a non-optional string. And so this is a time where we will need to actually unwrap it here. So what I'm going to do is I'm going to say guard let name equal our name text field dot text. We're saying I have to have this name, otherwise it's like a no-go. I can't do anything. Just stop the function here. We can't move on. And then we'll also grab the distance from our distance text field here. And I'm going to actually call this distance string here, and I'll show you why. So I'm just going to put a comma between here, this line and this next line to make it so that I can unwrap multiple things with one sort of guard statement here, and I don't have to guard let name equal name text field dot text else return guard let this thing, guard let this thing. It's just a more concise way to unwrap multiple optional values at the same time. And then what I'm going to do is finally make a distance here that is a double version of our distance string. And as you write out distance string, it's probably not going to autocomplete for you, at least mine didn't. And that's normal because we're kind of in the process of still writing this guard let statement. We haven't quite made an else statement, and so it just doesn't actually pick up that this is a valid constant that you can use quite yet. And so if I put else return here, then it should be all good here. We should get these 2 warnings, but that's to be expected. So what I'm doing here is I'm saying, okay, I'm going to put in some star and some distance. So I'm grabbing the name of the star, putting it into that constant, and then I'm grabbing the distance and putting it into that constant for the distance string. However, this is still a string. It's just text coming out of a text field. It doesn't know that it's just a number. And in theory, I could put in anything I want in here. So what I'm doing is I'm also saying, well, I need to take that distance string and make sure that it can be converted into a double here so that I can actually use it as a argument here for my create star function. Otherwise, if someone isn't using the app right and they put in any text that they want, then we obviously can't create a star from that.
I'm getting a hard error of definition conflicts with previous value.
Okay, so did you call this distance right here?
I called that distance. Oh, no, I called the second one distance string.
Oh, that would be it. Yeah, they just need to be a little bit different, and that's why I'm just putting distance string just to let me know. It's not actually the distance quite yet. So from here then, all we need to do is say name and distance, distance, from these 2 arguments here. So we'll pass in name right here and distance right here. Oh, and that got rid of them. That was weird. There we go. And so we just create the star from those values that we've taken from our text field here. We need to do one last thing in here, which is remind the table view that it has some new information. If I've just added something to my array of stars, remember that, just watch me here, you don't have to go here. If we look at this create star function, remember that it's it's initializing a new star, but it's also appending it directly to my array of stars, which happens to be what we're using down here in our table view as the data source. So if I say, hey, I've got a new star, I want it to be shown, how do I tell the table view to show new information?
To reload?
Yeah. So we're going to say table view, go reload your data. So let's try this. We should at the very least be able to have the app work in the sense that we can add stars here and have them show up in the table view. We haven't quite got to the point where we can save stars, persist them, but that'll be our next topic here after we take a break. So I should be able to put in a name and a number here, hit create. Oh, what did we forget? I totally missed something. And this was totally not on purpose.
In your view did load, you have to call the table view dot data source.
Yep. I totally forgot to set this view controller as the data source. So it's never, there we go. Sorry, one sec, guys. Okay, welcome back, guys. I am so sorry about that. That was, I guess, good timing to take a break anyway, though. So hopefully it wasn't too loud for you guys while it went off. Okay, so as far as Harmony's question goes, yes, it's just reloading the information in the sense that really all it does is it triggers the table view data source functions to run again. So again, it's just asking the table view, hey, how many rows should I have and what should the cells look like? And then it just sees, oh, you've got one more star. Let me just make a new cell for that. It just runs through that whole kind of process of making cells again for you, more or less. Again, so sorry about that, guys. So I think it was Wesley that pointed out what we need to do next is we need to set our view controller as the data source for the table view. So we'll say table view dot data source equals self. I'm just gonna put a line right here to say that's what we're doing right now. And then once we have that, now it should actually work. Create, there we go.
Can you just remind me? I know you just said it, but what you just did there and why it works?
Yeah, so really this is just following that delegate pattern. So we're specifically telling the table view, again, which is just a view. Think of the views as basically dumb. They don't really know much for themselves. So in other words, we need to say the table view needs to ask someone what, how many cells it should have and what they should look like. And so what we're saying is, hey, I am specifically putting myself, or in other words, the view controller, the star's view controller, as the data source to let you know who needs, or let the table view know what cells it needs to display. And then in doing that, it's then able to know, oh, I need you to call these, or it's basically triggering these two functions to actually be called to let the table view know how many rows it needs and what those rows should look like. So it's just sort of triggering that communication back and forth from the table view to the view controller, saying, what information do I need? The view controller then responds by returning the amount of stars that we have and then those cells. All right. So how are we feeling so far as what we've done so far, obviously, but specifically with the added model controller here? Like, do we feel okay with this? Is there anything you want to review before we kind of switch gears and talk specifically about now persisting this data?
Can I see like your line like 39? Can you scroll up a little bit?
Yeah. Yeah, so and then just to be clear for everyone, we just added this line right here in the viewed load.
So that for line 39, that table view dot reload data is just pretty much updating after every time we pass in an instance of a created star.
Yeah, it's just in a nutshell having the table view see if there are any new cells that need to be made. And it sees, oh, you just created a star, right? If I make another star, I hit create here, it will hit this create star. So that gets a new star added to the array of stars. And then it'll immediately say, oh, we've got a new star in the table view. Let's reload it. And then it sees you've got another star here. Yeah, as far as the data source equals self, that is what's telling the table view who to ask. So again, that would be like, me saying, or let's see, I guess we could go like this. Again, if we were going to our example of like me sitting right out at the window and looking out for the mail, and you saying, hey, Spencer, can you let me know when the mail's here? It's like you're kind of setting me as the source of your data or the source of knowing when the mail is here, right? You have to basically tell the table view, hey, I'm the person you need to talk to here. So remember that self just refers to the stars view controller. So it's almost like the stars view controller is taking on that responsibility of saying, I'm going to give you the data that you need. Sorry, that's kind of freaking out. I'm going to give you the data that you need in order to, know what to put on the table view. If we don't do that, then these functions never get called. And that's exactly why when I ran it, nothing happened, is because even though we had these functions here, the table view never knew who to ask for the number of rows in the section and the self row index. Exactly. You'll take responsibility for the job. And the reason we sometimes don't do that is because if we are using a UI table view controller, it has that built in for you. But whenever we are using a table view in a view controller, we need to remember to do that. Otherwise, the delegate pattern isn't quite set up yet. That communication, it doesn't know who to talk to. Any other questions before we move on? Oh, let's see. We can use the model controller, but we can make the same things and create operation. Yeah, as far as the difference goes, it's really just a matter of keeping things kind of separate and compartmentalized so that when we start building out our app more and more and it gets more complex, it's easier to update things. So as an example, right here, we could maybe call this version 1 of the app. And now what we're going to do here is maybe implement version 1.1, where we're now going to persist our data. If we were using this create star function in more than one view controller, we're going to add a little bit of code in this create star function to persist that data. That means we only have to update this function in one place, because everywhere else would be using this create star function, as opposed to if we were just initializing the star, adding it to the array and saving it everywhere kind of individually, we would have to do that every place that we are creating a star. And it's just a lot more work when you could be potentially using the same code over and over again. And again, I'm not really expecting this to feel super natural, like, oh yes, I totally understand why we're doing this. Again, it'll come more when you get into larger projects as you go on, as you start to get into build weeks and labs, then it becomes something that is just invaluable. It's a great time saver, and you know that you're not, missing something, I suppose. Yeah, it's just kind of giving things a single responsibility, like Kenny's saying.
So actually, just to sort of jump off of that from Kenny, does that mean that each sort of file that you make for the model has its own file that is a model view controller?
A model
like
controller.
each one has their own?
Yes. It's a little flexible there, but I think the best sort of thing to do for now is just say, yes, everything has a model controller. That's your safest bet. Every model you make will have a model controller. And again, each one is just going to have its own CRUD, right? We need a function to create a star if this is a star controller. If it's a spaceship, we need a spaceship controller to create a spaceship as well, and so on. It's a little more nuanced than that, but thinking about it like that for now is completely fine. All right, we're going to go a couple minutes over. I apologize. The alarm definitely didn't help, and I appreciate the questions. I don't want to discourage the questions because all of these have been very much on topic. So it makes us go a little bit over sometimes. And again, I don't want to discourage that, but I think these are all really good things to make sure that I'm not just blowing through the content and you're not understanding. So I appreciate the amount of questions you're asking. It's fantastic. It's not always like this. Okay, so let's go back to the model controller. So again, CRUD is I would say, a good starting point. This is just where you can kind of start and think, I have no idea what I need to put in my star controller. Think CRUD. Does that mean that's all you should put in there? No. For example, we're going to add some persistent stuff. And can that be put in the model controller? Yes, absolutely. If you are persisting or saving instances of your stars, that should obviously go in your star controller because that's some way you're interacting with the model controller. So I'm going to go ahead and just kind of make a little bit of space for me here and make a mark. Have we talked about marks before? No? Okay. There's a little bit of special syntax attached to different comments, I suppose, like mark is one, to do is one, and I can give you a list of all of them, or a lot of them. But what it allows you to do is kind of separate out your code even further by making these comments. I'll show you kind of a cool thing that it does. So if we say even like persistence, you'll notice it has to be in this specific kind of syntax here where it's all capitalized mark, colon, space, dash, and then it starts to be a little bit bolded here. But what you get is as you kind of hover over here, you'll get, and maybe it won't work until I kind of move down here. That's weird. Normally it will say persistence here, kind of like even if I don't highlight over it. Not quite sure why that's not working. And also, if you click right here at the end of this kind of ribbon, it will give you a nice kind of separator line here. So again, keeping your code as kind of organized as possible is a great thing. Violet, do you have a question?
I just wanted to talk about marks.
Okay.
Because they also do the page break, don't they?
How do you mean?
1 second. Can I not? Oh, there's the annotate. No, the like right above mark persistence, there's a little line.
Yeah.
Isn't that create a page break?
Right
Like and
yeah,
over in the
well, this is what's currently on the screen here, and that line that you saw was just what line is selected. Is that what you're talking about?
no, the very little thin line.
Yeah, right here.
Yeah.
Yeah, that's if you put a dash right here. If you don't, it'll still create the mark like Kenny's saying, but it doesn't get this separator, which I personally always put a separator there. It isn't necessarily, I guess, a page break. It's more than anything just a visual separator.
It took me forever to figure out where the line separator came from. That's why I left that note there.
There are really cool ones like to do and everything, and yeah. Anyway, do you mind clearing out those arrows?
I didn't make those ones.
Oh, who made the arrows?
I might have. I didn't think I made them.
Well, okay. We'll deal with it. It's all good. Oh, there we go. Thank you. Whoever
Oh,
did.
I guess it was me. Sorry.
No, you're good. No worries. So as far as this goes, this is just a nice way to say, we've got a very kind of clear, like maybe we could even make a mark here that says CRUD. I'm not going to, but you can, again, kind of keep your code as clean as possible. So with this persistence, let's talk about this. We're going to need to do a couple things. So there are, just like we kind of saw in the objectives, there were a few different, look at this here. There are a few different objectives here, excuse me. And these all really have to do kind of with each other. They're very small pieces to this overall larger goal that is saving things to specifically a file. Codable. Codable is a very cool thing that we will talk about. It's kind of a consistent topic that we'll have. You will see it multiple times, and one of the times is today. One of the times is when you get into networking. Is the other kind of key time that you end up using Codable. But in a nutshell, Codable is well, it says it's a type alias, but really it's a combination of two protocols, decodable and encodable. And I like this definition a lot. It says it's a type that can convert itself into and out of some external representation. So it's essentially a way to convert, your model into some other kind of thing. So if you think about, has everyone been to IKEA, or at least know what IKEA is? It's like flat pack furniture, right? Okay. So the whole thing is you go to IKEA, you go to their warehouse section, you get a cart, and you buy like a table, and it's in this like tiny little cardboard box like this thin. And then you go home, you unpack it, and you build the table. Are the pieces when it's flat packed and the pieces when it is built the same? Yeah, right? It's the same, they're the same pieces, they're just in a different format or a different representation of the table. That's essentially what Codable is we're taking the same information and just turning it into a different format. So whether that is in the format of, for example, for today's project, a star, or in some other format, same information, kind of different representation of that information, right? That's essentially all Codable does, is it allows us to have our object be able to be converted between itself and some other representation. So like I said, this is going to become an ongoing topic. So let's go to the star.swift file where we have our struct star. The only thing we need to do today is put Codable here as a protocol adoption. The cool part is we get this conformance to the protocol for free. It actually turns out that there's one initializer and one function that are requirements for encodable and decodable respectively. However, Codable's smart enough to write those behind the scenes for you. And this is very hand wavy. And personally, when I started learning Codable, it's only been around since Swift 4, I didn't like it because it was very hand wavy. I didn't know how it was working. We'll learn about that later. But for now, all you need to know is once we put Codable, I'm just going to put Codable will allow our star to be converted into a different format. That's really all Codable does. I'm going to get rid of the mini map. I don't actually particularly like it. So again, it's just like by putting it as Codable, we're saying this is like some IKEA furniture that could be flat packed or it could be built, but it's the same information. It can just be kind of converted between different formats of itself. I'll talk about the different formats in just a second here. So great follow-up, Harmony. So let's talk about what those formats are. And that has to do with this second, or sorry, rather, I'm going to kind of skip FileManager for just a second. That is going into our second part of Codable, which is using both encoders and decoders. So Codable is purposely generic, and it says an external representation. It doesn't say what the external representation is, because there are many that you could use. We have two kind of built-in external representations that we can convert to and from. And then if you want, you can actually write your own encoders and decoders to turn them into some other format that you want. So today specifically, we'll be using PropertyListEncoder, but there's another one that I'll show you. And we've actually seen property lists before, very briefly, and it is that info.plist file. So essentially what we're going to be doing today is converting our model object, which is the star, right, with a name and a distance, into this format here, where it's really kind of XML here behind the scenes, but it's just, essentially it's going to say For the key here, it's going to say serious. And then for the value, it's going to say 200. We just put it in a different format. The reason that we're doing this is because our model object, the struct star, is something that we have created, and it's basically only, it only really exists within the confines of our app. If we wanted to save it somewhere else, like on our phone's hard drive, which is what we're going to do, our phone doesn't know how to format that. It doesn't know, what a star really is as far as outside of our app goes. So in order to make it so that our phone can store it in an actual file somewhere, we have to convert it to something that it does know about. In that case, we're going to use a plist because it's like, oh yeah, I use plists all the time. I've got one in my info.plist. I know how to save that as a file and recognize it. And that's the whole goal, is to just kind of flat pack our stars into a different format that iOS can recognize and save. On a conceptual level, does that kind of make sense, what we're trying to do here? Okay, so again, something that is very specific to our app into just like a normal file type, like a .text file almost, in a sense. Sorry, Joe, did you have a question? Or
never. I'm all good, thank you.
Sorry, I didn't actually.
I don't know if it's sort of tangential, but that seems like a really bad way to save information.
Yeah, you're not wrong.
Is this sort of the normal way that this is done?
No, this is an easy way of getting into the concept of persistence. The much better way to persist, especially large amounts of information, is using core data, and that is a lot more efficient. It's just, we have a whole week that we go over core data. It's a much more in-depth topic. So we'll be talking about that in Unit 2. This is just kind of to get your toes in the water of persistence. But you're definitely not wrong. This is not something that you would by any means do at a very large scale. It's not meant to scale. This is great for small amounts of information, and that's about it. So yeah, you're 100% right.
On the job, would we ever use persistence like this?
Yeah. I maybe not specifically with a property list, but going into this second, third objective here, which is using FileManager, this is something that you would use on the job. So Codable lets us turn our objects into something else. We're going to use a PropertyListEncoder to specifically turn our stars into a property list. And then in order to actually save that to our phone, we're going to use FileManager. And that's, you could think about FileManager as a in-code form of Finder, where we're just able to access our phone's file system, right? It's just got its own folders and everything, and we can just save it somewhere there. So we may not actually on the job be using specifically, saving our app's information to a property list, but what you would be doing is sort of this latter part where you often would store like images, for example, using FileManager. That is something fairly common that you would do. So let's kind of take a look at this here. Let's go ahead and talk about FileManager real quick. I'm not going to go super in depth on this because for one, you can't do a ton of this stuff with iOS, but it's more just to kind of show you that it's basically Finder. So like it says, it's a convenient interface to the contents of the file system. So you can think about it as basically anything you could do in Finder, like, copy, open files, duplicate them, you could do with FileManager in code. So we've got create directories, replace items, copy items, move items, etc. It's really just kind of a programmatic in-code Finder. And iOS is fairly closed as far as, you're not able to access your whole iPhone's file system. However, each app is what you would call sandboxed. And so it has its own kind of container that within it, it has its own smaller kind of a set of folders here. You could almost think about it as each app being a user. And so each user in Finder has like a documents directory, a downloads, movies, music. It probably doesn't have movies and music for every app, but it does have a documents directory, and that's where we're going to ultimately be saving things today. So we just use FileManager to access that and be able to save them to essentially where we want to. So let's do that. Do we feel okay with those three things on a conceptual level? Codable, PropertyListEncoder, and FileManager. Okay. So let's go back to the star controller. And now, one thing we need to know is basically where are we going to save and load our stars from? That's kind of the whole kind of overarching question is like, if we're going to save it to a file on our phone's file system, where is that, right? We kind of need to decide, just like we, decide every morning, hey, I'm going to put our project in our development iOS16 folder. Like that's a conscious decision that we make. We need to kind of do that right now in code and say, where are we going to save our stars to? And what we actually are going to use are URLs. So I'm sure you're used to URLs just in like a browser. Google.com is URL, but your file system actually has a URL. Just like if I go into the terminal here, if I do pwd, that's essentially, it's a path, but in a sense, you could think of it as a URL. It's just a location not on some server somewhere, but it's just a location on your file system, right? It's just some resource location, in this case on our iPhone. So what we're going to do is we're going to make a computed property here called persistent file URL, and I'll talk about why we're specifically making this a computed property. It has to do a little bit with how iOS works. It's a little bit finicky here. So let's grab our file manager. So I'm going to say let file manager equal, we're going to grab file manager dot default. So that's just a built-in instance of file manager. We don't have to create a new instance. It's kind of got one for free. And so we're going to put everything in the documents directory. So I'm going to say grab the documents directory. So in other words, it's essentially like if we did something like, my user / documents. Oops. Something like that, more or less. So what we're going to do is we're going to ask FileManager for that documents directory. Since this is just like on a Mac, it's sort of built into every user that it just comes for free with a documents directory. We can say, let's do let documents, and I'll just do dir for directory. We're going to say file manager, that lowercase f file manager, that one that we just created right there, dot URLs for in. So it should only be one URLs. And then these are both enums here, the for and in. So the search path directory, if we hit dot here, we can kind of see more or less kind of these things here. We've got this libraries directory, applications directory, desktop, developer, documentation, downloads, etc., movies, music, pictures. Again, this is more useful when you're using macOS, but an app does have the document directory, and that's what we want to specifically figure out where that is, just the location to that. And then this in, we're going to say dot user domain mask. So again, that's like specifically going to your user. And in the case of iOS, that's really just your app. That's actually something that you can access. It's a little bit weird, and I don't expect you to feel super comfortable with FileManager. But if you could, you could even make a code snippet of what we're making here. Getting the documents directory is common, but as far as an iOS app goes, that's really all you use FileManager for. You never really use it for, getting, anything other than the document directory. It's just about that. I'm going to say grab the apps documents directory specifically. And this is a URLs, so it actually returns an array of URLs. So potentially there could be more than one document directory if you went to a different domain mask for like all the users or something. So I'm just going to say I want to grab the first one because there should only be one here. And then we're going to create a unique location for the stars property list, plist. So this is actually a URL type. It's actually its own data type. It's not like it's a string or anything. And so it gives us some helpful tools to kind of add on and say, well, if maybe my documents directory is, documents, then adding on and going down a level, or talking like this buildweekstandup.md, that is not just this URL like my user/documents, but it's like my user/documents/buildweekstandup.md. So if you want to add something onto this URL, there is a helpful tool. So we're going to say let stars URL equal our documents directory dot, and then we are going to use this appending path component. So be careful here, and you'll learn more about URLs a ton in Unit 2 when you get into networking. Be careful here. There is append path component and appending path component. These do slightly different things. We want to use the appending path component. And if you're curious, I can talk about that another time, kind of what that does. And then we just need to kind of make a unique file location, just like this bwstandup.md is its own unique location. So we'll just maybe call this stars.plist. And so now I've got something more like my user/documents/stars.plist. And that will be the location of our property list to save it there, but also to pull it out. And then finally, we'll just return that stars URL, and then it'll stop yelling at us here. This is not really tangential, but it's somewhat supplementary knowledge. But if you are ever saving a URL to the documents directory, you need to be a little careful. The URL actually can change, and I can run this here in a bit, and I can kind of show you what it looks like. There's a bunch of just this unique identifier, just kind of these garbage characters. The problem is iOS is always shuffling that around, so the location actually changes a little bit. So if you just hard code that URL location in, it may not work sometimes. So in making this a computed property, it will always ask and see like, hey, I need to just get the location of the document directory, and it won't matter regardless of if, sort of that identifier is changed at the end, it will still give you the right location every time. So this would be a great thing to like just kind of make a code snippet of, or just kind of save somewhere. I can talk about making code snippets later. If we weren't so late, I would do it now. But accessing the documents directory is going to be basically, these two lines always, and then just adding on some unique location to it. Yeah, so really quick, it's just basically us deciding where do we want to save our stars file to, and that's basically it. No, we haven't quite saved the file yet. It's literally just us picking out the place for this, but we haven't even saved it quite at this point. I'm just saying, like, kind of marking my territory, like this is the exact place where I'm going to save my file eventually and load it from.
I don't really understand what this code's doing, like what it has to do with like where the plist comes in and stuff. I was reading the stuff yesterday. I didn't get it then either.
Okay, let's write the last two functions here, and then I think that will make sense, because right now this is just more than anything setup and preparation to save that. We haven't quite gotten to saving it yet. So I'm going to continue, but please remind me if I don't, I don't answer your question. So again, just think of this as a location. That's all it is. We haven't used the location. It's just preparation. So let's make another function here called save to persistent store. Whoops, store. And so what this is going to do is save the stars array to the persistent file URL. So that would actually be like us going to that place in Finder, that location, and saving the file, saving that information. Okay, so the question is, what do we want to save? What information in our app do we care about saving?
The star, which is the star struct, which is the name of the star and the distance from the sun.
Yeah, and we should probably just save them all. So we're going to specifically use this array of stars up here. So we just save everything, but you're exactly right. In order to do that, we're going to make one of those, like it says here, property list encoders to save the codable objects to a file. So this is going to introduce a new concept here, and I don't want you to freak out. Let's write this out. We'll talk about it a little bit. I may have already recorded a video, like a supplementary video on it. If not, I can also do that, but I'm fairly sure I did. So we're going to say, put this do keyword here, and then open up a curly brace and hit enter and close the curly brace. And then we're going to write catch on this same line as that ending curly brace. And then I'm going to open up curly braces again. So we've got do, curly braces, catch, curly braces. It's called a do catch block. You'll see this often, well, fairly often, and we'll talk about it. I want to write this out first, and I want you to, at this point, just ignore it for now. We'll talk about what this does, but let's just focus on this code here. So I'm going to say let encoder equal property list encoder, and we'll just initialize that. Then I'm going to say let stars plist equal, we're going to put try encoder dot encode stars. Okay, so I'm going to say create the encoder. This is going to convert the stars into a plist, or encode it into a plist. Then we need to grab the location that we want to save the plist to. So this would be like, think of this as an actual file here. We've got this plist file, so now we just need to decide where we want to save it to. And I'm going to say we want to save it to this persistent file URL that we made up here. So I'm just going to say, we need this to be unwrapped, and I'll show you why in a second, but we'll say guard let, we'll just call this like stars, or I'll be consistent here. We'll call this persistent file URL equal persistent file URL, else return. And then finally, we're going to say try stars plist dot write to persistent file URL. Save the file to the documents directory. All right, so let's break this down. First line here on our encoder is creating, essentially, you think of it as like the machine that's going to take all the parts and flat pack it into, you know, the star, but in a different format. This is the actual conversion of that. We're actually saying, take the stars array. Again, that's if I highlight this and I scroll up, it's highlighting my stars bar up here. So I'm saying, take all of the stars in this array that I have currently. Again, you know, when the app's running, we'll actually have some stars in that array, and turn them into a property list and encode them into that format. It's like, okay, cool. Then what we do is we say, now that we've got that property list file, we need to figure out where we want to save that. So we grab that persistent file URL, which again is just some file in Finder here that we're going to say, I'm going to have it go right here as opposed to on my desktop or something else. And this is where we actually save the file. So we're able to say, write our property list to a specific location. And that's the actual saving and putting it in the, you know, in that location in Finder. It's like this line of code is essentially what we do when we say like save or save as. It's literally going to call this right to some URL and save the file over again.
Can you scroll up to about line 30 for a moment?
Yeah.
Can you explain the code on 34 and 35 again?
Yes, this is just finding, it's in code, think of it as the process of me going in Finder and looking at my documents directory. We're just finding this specific folder here.
But I mean, like, can you explain like where that code's coming from, like how you knew to use that code?
Practice. I mean, really, FileManager, again, think of it as Finder. And then we're saying, hey, can you give me the URL or that specific location for my documents directory? Or you could say for my movies directory. It's just, I don't really know what to say other than that. Just, you would either just, you know it just from doing it, or you would look in the documentation and figure out, oh, this is how I can access, you know, the different kind of built-in folders in my file system. I think this is a point where, again, I'm not making the assumption that you'll feel comfortable with FileManager. There's a lot to it, and you just don't use it that often. But when you do use it, it's generally going to be just this exact code, which is why I say you could make a code snippet of it. Yes, the else return is just saying if we don't have the persistent file URL. So for example, for whatever reason, if our documents directory isn't there and for whatever reason this is nil, then it just exits the function. We say we can't do anything else. Ron, do you have this stuff up here?
Yes.
Okay, perfect. So let's address the elephant in the room, which is this do, this try, this catch. What is this all talking about here? Well, it turns out that we actually have functions that sometimes could not work actually the way that we expect them to. So think about it this way. What if I say, hey, can you save this file to a folder that doesn't exist, for example? Maybe I don't have a documents directory for whatever reason. It would be a super random edge case, but in theory it could happen. So it could be that when we try to write it, our stars plist to this location, maybe the location doesn't exist, or maybe it's at a part in our hard drive where we don't have the permission to write to it. There could be all of these reasons that it could fail. And so what the function does is if I option click on this, you'll actually see at the end it says that it throws. what a throwing function means is that it could fail. And if it does fail, what it's going to do is throw an error out to you. And it's literally going to say, sorry, and I'm going to throw you the reason why I wasn't able to, do what you wanted me to. And same up here for our encoder.encode. There could be, for whatever reason, we're not able to actually encode our stars. Maybe it's not in a compatible format for whatever reason. I actually don't know the specific edge case that this one wouldn't work on the encoding, but in theory it could not work for whatever reason. And so what happens is if at this time or at this time when we try to save the property list, if there's a problem, what it will do is it will catch the error, and we're able to handle the error here. So I'm just going to put as a comment here, handle the error that gets thrown, thrown here. This catch statement, this chunk of code will only get called if there's a problem. So if everything works great, then it'll just completely skip over this and nothing will happen. This would be more than anything a place for you to, one, handle the error, at least print out what the error is, if not also maybe, show to the user some alert saying, hey, this didn't work, try again or try later or whatever. So for us, at the very least, what we're going to do is just print and maybe say something like error saving stars, and then I'm going to interpolate an error here. Now this error is it's a property, it's a constant that just gets made, but it gets made for you, which is a little weird. If you try to build this or you try to click and have it highlight, you notice it doesn't actually highlight anywhere, which is a little bit weird. It's like I never made a constant called error, but why does it build successfully? Well, that's because, again, only in this catch statement is there going to be an error that's thrown. So if it gets into this code, in this catch, no matter what, there's an error. Something went wrong. It just happens that it calls the name of the error. It calls that the identifier of the constant error. If you wanted to, you could, if that feels weird to you, you could call it something else, and you could do catch let, like save error equal, or actually you don't even say equal, say catch let save error, and then that's what the name of this becomes, is now save error. I tend to just leave it as error, but if you really want, and if you're doing a little bit more intensive error handling where you're catching multiple times, that can be kind of a nice tool. So again, I'm just going to put this catch statement will only run if a throwing method fails. So on a throwing method like this write to or encode, in order to say, hey, I'm prepared to catch this error, we put try at the start. And then it says, hey, try to run this function, but again, if it doesn't work, go ahead and throw it down into my catch statement. So I can literally catch the error you're throwing at me.
So the try catch feels like kind of like unwrapping an optional that is a function.
In a sense, yeah, you could almost think of it like that.
Okay, but with that, could you can't unwrap an optional using try, could you? No. So like you couldn't change the guard let into like try let.
No, on a conceptual level, they sort of have parallels, but they are completely different as far as their actual implementation works. So here's the good part. If you're ever unsure about like, well, okay, well, when do I need to use this? How do I know when I need to do a do, try, catch? The good part is Xcode is really good at letting you know when you need to do this. So for example, if I get rid of this try, and you can just watch me here, it's going to immediately yell at me and say, hey, call can throw, but it's not marked with try. So it'll let you know. And even if you put it outside of a do, you don't even have that do, same thing. So it's good at, oh, well, if if I had all of that stuff, it would be completely fine. So it would be able to, you know, tell you when you need to do that. Now, as far as this goes, let's look at the options it gives us to fix it. It'll give us a couple options here. It'll say, did you mean to use try, which is what we should be using. We could do this where we say try with a question mark. I don't want to confuse you too much. Basically, okay, I'm going to talk about a couple ways of doing this try. When in doubt, just use try naturally like that. That's the best way to do it. As far as try with a question mark goes, this says, I don't necessarily care to catch the error. You can only put a try statement like this inside of this do. If you try to put it outside, then it'll say, hey, can you put this in a do? Let me see if I can get that to work here. Right, so it's saying errors thrown from here aren't handled, meaning you need a place to catch them, and you do that inside of this do catch kind of block of code here. So as far as the try with a question mark goes, you're basically saying, yeah, I don't really particularly care to catch the error. So I'm just going to put try here, and it's going to say, I don't need to do this stuff. Or at the very least, you know, catch the error. Can anyone think of some potential problems with this? Potential, not always.
It kind of removes the ability to debug.
Awesome, that'd be perfect.
Yeah, exactly. And that's a huge thing. If we're not really giving ourselves, even at the very least, a print statement to see what's going on, that's not going to be great. That's, you know, you're going to spend so much more time debugging your code than you are taking like the extra 15 seconds to write a do catch little block of code here. So I would always recommend using a do try catch. There are some times where it's like, yeah, we don't really need to, but a lot of times it's a great choice to just put catch in here. Put in a do try catch. I promise it will save you time. So, and then just like optionals, going back to kind of the concept of, you know, almost a parallel with optionals here, we also have a force try, which, can you guess if this is a good thing or not?
Bad thing.
Bad thing. Remember, this is like the bane of our existence. Please never do this. You will see this there. Okay. Please never do this unless we tell you to. There are times, and we'll actually show you one, I think with core data, that it's like, it's a perfectly acceptable time. But again, they're more of an exception than anything. So just for now, don't use it. I just kind of went a lot over, or very quickly over, try with a question mark and try with an exclamation point. Again, this is what you should be doing. This is the best code that you can write as far as these throwing functions go. Okay, questions on this function, questions on do, try, catch, all of the above, none of the above. How do we feel?
I kind of think this is just more something like when we use it, it's going to make more sense. You know, like the more we use it.
Definitely. And again, luckily, Xcode is really good at letting you know when you need to do this. And if anything, you can either option click on the function after you've written it out, or you can see as I start typing right, on the right here, it puts, whoops, it puts that it's a throwing method. So it'll tell you. As far as Harmony's question of what does the do mean again, that's just saying in this sort of chunk of code within this do, you know, curly brace section here, that's where you can use the try keyword without having to use try with a question mark or an exclamation point. So all of the try functions that you're trying to call, literally trying to do, need to be done in the do. Closure, sorry. Try to do this, do it in the do. There's a lot of the same word there. Okay, so if this is the thing that's actually taking our array of stars and saving them, when would we maybe want to call this function? What would be a good place? There are multiple, but any ideas on where we could maybe call this function?
The view did load is probably a good idea. It's right after you open the app. It's the first thing that loads data.
Okay. Yes, you're right. Although we wouldn't necessarily have any data quite yet if we're trying to save it. That would be good if we're trying to load it, and that's probably what that's one place that we can do it. But what about when we
Oh,
want
I thought that's what you were asking, is where to load it from. I thought we already saved it to the documents directory.
No, this is saving it to the documents directory right here.
So when we're adding a star?
Yeah, probably like when we're adding a star. Cody, you're exactly right for the next function we're going to write, though. So that's the cool part, again, about these model controllers is everything is using this create star function. Right after we append it to our array, there's nothing saying we can't just immediately save that to our file. So as soon as it's created, then we just immediately save it to the file. So if the user closes the app immediately after they, hit create star here, it's still going to be saved. And that's the great part. And that's all we need to do. So if we had a function, for example, to update a star or maybe delete a star, we would also probably want to call save to persistent stored there as well. In this app, we just don't have one, so we're not going to do it. Okay, how do we feel about this function again? Is there anything else I can go over before we move on? We have one more function, and then we're going to talk about file organization, and I will let you go. I'm so sorry for going over time. Okay, all right. So the last function we're going to make is basically the opposite of this, where we're, instead of saving something to that file location, we're just going to load it from the file location. So we'll call this load from persistent store. To be clear, this is just like a common name for these functions, but there's nothing special behind these names. You could call these whatever you want. Save stars, load stars, it doesn't matter. So we're going to essentially do the same thing, although we should probably check first of all and make sure that we have the location to the stars, otherwise we can't really do much. You could argue that we could do that here, like basically this line up there as well. But so we're just going to say guardlet persistent file URL equals persistent file URL, else return. Can't really do anything without that location. That's kind of the key to these functions working. So we'll say do. So we'll create our, let's call this a decoder actually. And this is going to be a property list decoder. So just like we had an encoder to turn it into a property list, we have a decoder to turn it back out of a property list into our stars. So create the decoder. And then we're just going to grab the data, or in other words, the plist from the persistent file URL. So we're going to say guardlet stars, or sorry, not guardlet. We'll just say sorry, man, I don't know why I keep saying guardlet. Say let stars plist equal, and then we're going to use a initializer called data. This is a struct data. It essentially represents anything. It's sort of like, it's a bag of zeros and ones. So it could be, the data could be a JPEG, it could be PNG, a PDF, it could be a property list, it could be an entire .app file. Data is just some data on your file system, basically. It doesn't even have to be on the file system per se. There's a lot of ways that you can create data and initialize it, but the one that we're looking for, the initializer we want, is this contents of URL. So we're going to say, hey, here's the location to a file. Can you get me all of the data at that location? Does anyone notice something interesting about this initializer here?
It throws, so you don't need to put a try in front of it.
Perfect. Yes, exactly. So let's put persistent file URL for the contents of, and then we'll put try right there because it's a throwing function. And it's really as simple as that. If you forget to do it, then you just say, oh, let me put a try there. It's very forgiving, I suppose, in that sense. And it's saying that the errors are not handled, so I'm just really quick going to add that catch block of code there. So now that we have the plist, we need to turn it from a plist to our array of stars. That's kind of our goal here. So we're going to use that decoder to do that. So we'll say let stars equal our decoder dot decode. And then, sorry, let me do that one more time. We have a couple options here. We're just going to use this one with the type and from. We don't need to worry about a format. The default is actually going to be great for what we have. So this type is, how do we want to turn this back? Like basically we have this in a property list right now. We need to decide, well, what format do we want to turn this back into? Is this an array of stars? This is a dictionary? Is this an array of view controllers? We just need to dictate how to try to decode it. We're going to say this is going to be an array of star. Then we're going to do dot self here. This looks a little bit weird, and I'll talk about what we're kind of saying with this. And then from our stars plist. So take the plist that we just got from our file URL and then decode it as an array of stars. And what did I miss? What did I forget? And this is completely not on purpose.
Try.
Yeah, the try. So just put try right there. So this, when we say we want to decode it as an array of star, we have to put this dot self right here. What this is meaning is we're not referring to a specific instance of an array of stars, but we're referring rather to the type array of stars. So it's just, again, we're referring to the idea almost as array of stars, whereas if we put this, it almost thinks that this should be an array of instances of star, and that's not quite what we want. We're just saying, what is the kind of blueprint or recipe that we should decode this property list as? And if I option click here now, I have an array of star objects, exactly like what we had sort of at the start of this whole thing. And we're not using it right now. So where should I maybe put this array of stars for it to actually be useful?
And just put it in the array. Stars are.
Yeah, we have our stars array at the top here. So all we need to do now is just say self.stars equals stars. So the stars is going to be right here. Stars array is the one up there. And again, that stars array is kind of that whole key to our app, because that's where the table view is looking for its information and everything like that. So that's ultimately the place that we kind of want to restore the stars to after we load the app up. And again, in our catch statement, just in case something doesn't work, let's just handle this really quickly, and we'll just maybe just print error decoding our stars. This isn't a great way of error handling, but it'll be great for what we need right now. And we'll just interpolate that error so we can at least see why it's not working. Excuse me. So Cody earlier said we should try to load them as soon as the app loads, which it would be like in the view to load. That's a great option. There's one more option that I would sort of submit, although if you want to do it in the view to load, I think that's a fine place to do it. We also have access to the initializer of this class, and we don't necessarily need to do anything like pass in any values, but what we can almost use it as is like the, I'm going to say like the view did load in a sense of the star controller. In other words, the first place that we can call some code in the star controller. I personally enjoy putting it, like calling this load function in the star controller itself, because again, I'm trying to keep this as compartmentalized as possible. However, if you want to just say, you know, star controller.load from persistent store in your view controller, I think that's also fine as well. So what we're going to do is we're just going to call init like this. We don't have any arguments or anything, but what we can do is call load from persistent store here. So let's talk about where this is actually going to get called. That would be, I'm just going to kind of pull this over on the, you don't have to pull it over in the assistant editor, but this right here, when I call open and close parentheses right here, that is this initializer right here. So as soon as we create the star controller in our view controller, it'll just load from persistent store. Or again, like Cody suggested, we could also just do star controller dot load from persistent store there, more or less the same thing.
Can you scroll to the bottom of the star controller real quick, please?
I was just going to do that.
Thank you.
Yep, you're welcome. So hopefully you can see that more or less these two functions are the same. They basically do the same thing, right? One is just saving to the persistent file URL, and one is loading that from that persistent file URL and just decoding it as an array of stars instead of a key list. For you guys that have this, go ahead and run it on your simulator. You should be able to have the app work so you can you know, add some stars, hit the stop button once you've added a star or two, hit the play button, and it should show up back again on your table view. And if I do it, I think because we've called this the same file that I already had. Oh no. Yes, so as far as encode, encode means to turn it into a different format than the model. So turn it into a property list or JSON or some other file type that could essentially be saved to the phone's hard drive. The decode is the process of doing the exact opposite, where you take that file type and turn it back into your model object. So let's go ahead and do, just gonna say like Sirius 200, hit create here. I didn't get anything in my console, so it looks like it worked. So if I hit stop, hit play again, run it, and then I have Sirius back up, just with those two functions and the persistent file URL. Okay, does anyone else need me to go anywhere real quick before we finish up? All right. Okay, again, I'm so sorry for going over time, guys. I went almost an hour over. That is, I'm gonna make sure that never happens again. Although I wanted to make sure that I didn't just fly through this last bit of content here. So I apologize. I'll do better next time. Please let me know if you have any questions, and again, take your full hour lunch, and then, you know, come back and at about 2 o'clock here, or 1 o'clock, and then go ahead and get started on your afternoon project, okay? Awesome. All right, thanks so much, guys. Talk to you later. See ya.
Thank you.